And welcome everyone to this month's Connect with Remedy webinar. Today's topic will be on end-to-end integrated proactive service management. And during the presentation, you can ask questions during the Q&A panel. These questions, along with a live Q&A, will happen at the end of the presentation. And at this point, I will turn it over to Darius Wallace to take us through this content. Darius?
Thanks, Greg. Welcome, everyone, to this session. We put this together based upon a lot of interest in the ability to transition from a reactive mode of operation to a proactive mode of operation. And we've worked with several customers, but one customer in particular went through this journey. We were able to document it and get some tangible results. It was deemed worthwhile to kind of make sure that we shared a portion of this journey with the team and the larger audience for the benefit of everybody to kind of see how that journey was taken and how those results were achieved. So that's kind of what we're focused on. Please pay attention to the big picture. Service management is at the center of it, but by itself, it's being leveraged in combination with other capabilities of event management and those solutions. So we're going to look at this end to end. We're going to establish the goal, set the objectives that we put in place in order to address that goal. We're going to look at what it means to execute against a proactive service management flow. We're going to look at the high-level architecture that we put in place to kind of prove out the concept of how this would work. The important thing to note here is that when we went into this, we wanted to establish proof points before we took the larger step of moving this into a production environment. We'll talk about the differences of what it means to have monitoring coverage at different levels. We'll give a brief and go through a brief demo that shows some of the results that came from the views that we were able to establish and how those views helped us make decisions about how we would tie alarms and alerts into generating the incidents that we would ultimately act upon. And then we'll close out with what we observed from this proof of value, proof of concept exercise that actually started getting used against the production environment as a part of the steady state operations. So with that in mind, let's just kind of jump in and establish the goal right up front. The goal coming in was to establish stability in the remedy environment. There were circumstances that was going on for a period of time where outages were happening in the environment. The team was in a very reactive mode. The way that they knew something was going on was a result of customers calling in saying some aspect of the system was down or they couldn't get into the environment. And then they would scramble and pull together and do a lot of great Herculean work to trace the issue, resolve it, system would come back up. Now, that's the reactive mode. It never really gave them an opportunity to pivot and focus on other activities such as innovating in other areas, because when these things hit, it was all hands on deck. And the goal here was to establish stability in the environment, and the way in which to achieve that was to move from reactive to a proactive mode of operation as they looked at this environment. In other words, they're starting to try and address things before it affects the end users, getting in front of these items and working issues or anomalies that happen before they become events that result in outages. Now, that all sounds great in theory on paper. Being able to do that results in other benefits in the environment, like improving your efficiencies and MTTR metrics and things like that. The tangible thing that we're hoping that we'll be able to pull out of this session and share as a result of this actual experience and going through this journey with the customer is the tangible things that were done that actually produced that result. I'm going to give the punchline now, and then I'm going to repeat it at the end. After this exercise, we went from a very unstable environment, things were up and down, a lot of tension, a lot of concern about the stability and credibility of the environment, to moving into 3 to 4 to 5 months straight where there were no outages for that period of time once we start putting some of these processes in place and started leveraging some of the output from these activities. More importantly, when an outage did occur, the way in which the team engaged was fundamentally different. Able to isolate on the issue, understand who to engage, and they were able to understand what to focus their attention on, as opposed to chasing what I would call events or squirrels that are just running around in a general sense. They can pull the team together and isolate on what the issue is to get the system back up and running, and then take the output of that and roll that into what was necessary so that they can prevent that particular scenario or address that blind spot that hit them because they may not have known that that was an exposed area. So therefore, they updated the system so that they didn't get alerts or have visibility into that particular area. And that's now the mode of operation that goes into a more stable environment, and when there's an unexpected occurrence, how they take the results of that, get the system back up in a reasonably fast period of time, and then roll that experience into ensuring that they protect themselves on the next go round. So there was a set of objectives. Now, again, to be very clear, because this is a real customer experience, it all sounds good on paper, it sounds good on slides, you hear the marketing stuff and all that great stuff. They were very clear. They said, look, we're going to be looking at how the event management aspect of this can help us improve our environment and get this goal of going to proactive service management and be proactive in our activities. Let's be very clear about what they had. They already had event management activity. They already had monitoring going on in the environment. We were bringing in the TSOM environment. They were currently running, BPPM as a solution. They had other monitoring solutions out there, and they, to some degree, were using BPPM as the monitor of monitors, the manager of monitors, but at the same time, they weren't getting the results. Alerts were going off. People started getting numb to those alerts because all alerts were given the same priority and the same urgency. So we wanted to demonstrate that it's not a matter of the technology that's important here. It's a matter of how you apply the technology at the right level, support it with people and process in order to get the results we're talking about. So we established some objectives for us to come out of this test case to get the following results. Wanted to make sure they had a presentation layer. They wanted to understand what that was. How do I get a single pane of glass for the different monitors and leverage their existing investment in monitors? Right now, we wanted to, not right now, but when they started this, they wanted to come in and they said, we have thresholds, but what's the baseline? How do we know that we're getting better? How do we detect degradation as opposed to just reacting to failures and outages? And these are some examples of things that we wanted to take a look at: the availability of the remedy servers, the mid-tiers, the different elements of the system. Other objectives wanted to demonstrate dynamic thresholds. This was very, very important. The key thing that happens here is that in the static world of doing traditional monitoring, you pick a threshold, you hope it's right, and if you hit it, that's great, but it may not be the right threshold. Something hitting a peak doesn't mean that it's actually a failure. It just means that you hit a peak and something hit an alert, and if that threshold is wrong, then you end up not paying attention to it over the long haul. And that's the key thing that we're trying to make sure that we leverage dynamic thresholds for. Let the system understand what's normal. It may be that there's a high CPU utilization on Fridays at this particular time every Friday. The system is still okay, but just because I went above 80% utilization of the CPU doesn't mean that I have an issue in the environment. On that Friday, that's what happens all the time, and that's expected. And so that understanding those thresholds and understanding how to understand what's normal by leveraging dynamic thresholds is very important. We wanted to make sure to have a clear understanding of the performance monitoring and event management capabilities of TSOM relative to what they're familiar with in BPPM. So upgrading into that next level of capability, want to make sure they had a clear line of sight and what things they would need to do different within that new environment. Also, another very key component was making the transition from static models into hierarchical service models so that they know that when something goes down, even if there's redundancy in place, they're able to know that they still have coverage and the service is still up and not overreact with every event. Within a static model, and without the consideration for redundancy in the environment, Static models are a good starting point, but the fact is when something goes down anywhere within that static model, flat model, it results in the service being lit up as being a failure, and people start getting numb to that because everything becomes an alarm. And then finally, you'll note in some of the material that we show in a few minutes, there was a definite disconnect in how the models were being managed. There is a model that is being managed in the CMDB, some information is coming in there, and then there was also a separate model that was being managed and generated in the event management side of the fence. And the goal is to have a single source of truth for the model to then be leveraged in multiple channels. So what we're going to do now is when we came in, we started with the conversation to make sure we looked at the big picture. We wanted to make sure there was a clear understanding that end-to-end proactive service management is not just about event management. It's understanding the relationship of knowing what you have with automated discovery, making sure that you're able to establish a context for what you have in configuration management. As the consumer of that information, have event management leverage that model to then align the alerts in that context. And then based upon that context, based upon the impact model definitions and correlation of events, generate the subset of incidents that would require attention. The expectation is you will get many events, you will get many alerts. What's important is to act upon the incident that you generate, not go off and chase all the incidents, or excuse me, chase all the events or squirrels that happen to be popping up in the environment. There could even be critical alerts that come in. But when you start tuning the system, even those may get normalized out to say it's not to the point where I want to generate an incident to act upon because I have redundancy in place and I'll manage that in my mode of operation when I'm doing analysis and analytics on a day-to-day basis about how the system is performing. So shifting from chasing events to generating incidents on a subset of those events and using your incident management system to track and drive the behavior of focusing on the right things. So these are the practice areas within our environment. We take a look at the products that we have available that support these environments. So there's Discovery, there's the CMDB, there is the BPPM and TrueSight solution, and there's Remedy ITSM. Turns out that this customer actually had all of these products. Every single one of them, they had them in place at different levels of versions implemented to some degree in silos. Discovery was feeding the CMDB, but the CMDB was not publishing to TrueSight, publishing to their event management activity. Event management was doing what it was doing, and it was actually generating some incidents. But it was generating incidents for almost every event that came in. And so looking at it from a more holistic fashion, that was our first goal, is to make sure that the end-to-end view was well understood and to make those connections. Noting, in fact, that once you have automated discovery, you're able to then create a view in the different swim lanes to understand what you have in your environment. So by populating the CMDB, you also have visibility into your service management space to leverage that for the processes around service management. TrueSight, or event management, also leverages elements about the infrastructure. You'll notice in this picture, which was drawn very specifically, that there are, in fact, a service model that is created in the event management space. And that is a service model that is different, or that was different, than the service model that was in the CMDB. So even if they were creating incidents from the information that was coming from the event management system, it was not being correlated with the actual CIs that were in the CMDB. So frankly, what they were primarily doing was just getting event-based incidents, right? So they were using pieces of it. They were investing in the silos and getting some bases in place, but we know where the starting point was. They still left them in a reactionary mode. What we started talking about was establishing a service model that was derived from information that came from the discovery operations. That would feed into the CMDB, and in doing so, we would be able to flush out a richer view of information that would be visible in the CMDB. More importantly, we wanted to make sure that service model was the system of record, and it, in fact, was the source for the event management activities for that model. And then based upon that information, we would then have policies, and we would then be able to tune the system on the event management side to create incidents in the context of those CIs, or those causal CIs, when appropriate, and leverage that information, which was also known on the side of the service management space. And this is what translates into what we would consider the end-to-end integrated service management. So that's the big picture. We started a session as a kickoff, as an orientation with the customer to first talk about the difference of the before. Again, at this point, it's still all just talk. It sounds good on paper. It's a concept. Yep, that makes sense. Looks like it puts things holistically together, and we can kind of get behind the concept. But the bottom line is we need some results. Putting this into practice is a different thing. So what we all agreed upon was what we will do is do something a little bit creative here. What we're going to do is set up and do a sandbox environment, but rather than do a theoretical setup of this environment, we're going to set up a sandbox environment that actually points at the production environment. And when we start getting alerts, they will actually be alerts that are from production. But when we generate tickets, the tickets or the activities will be generated in the sandbox instance of the service management solution. When we see the charts inside of TrueSight, the dashboards inside of TrueSight, they will actually be views of the production environment. And we'll be able to see the difference between what level of granularity and how we can look at things through different lenses compared to the the monitoring that they're doing through other systems today. Or not today, but before. All right, so how do we start this off? We came up and said, let's get some basic activities in place. We need to set up an environment that is a standalone sandbox environment that would support the TSOM environment, have an instance of ITSM, we went with 9.1SP4 at the time, and put in place a CMDB that is in the sandbox environment. It would replicate an aspect of production. And we put together this illustration. It would take a little bit to kind of go through this thing in detail, but just in simple terms, on the left-hand side, there's two primary components. It's a sandbox environment, and it's made up of a very focused and targeted deployment of TrueSight, and it is tied into a very simple and straightforward stack for the Remedy ITSM solution. On the right-hand side, this is all production. We took some aspects of discovery. We used the actual discovery of the live environment to populate the sandbox instance of the CMDB, which gave us our context. In the middle section on the production side, you'll see that there's some mission-critical, servers and services in place. You'll see a more detailed element of that. And you'll see above that the current production environment is using BPPM. In the very early stages, we were actually taking the events that were coming from BPPM. We were taking things that were coming from Nagios and SCOM, and we were taking those production events and also feeding them into the sandbox instance of TSOM. We later turned that off, and the reason we did that was because it was actually providing redundant information in the views that we were trying to provide. And what we were trying to emphasize is we didn't want to take how it was being done today and have all that extra stuff come in and then have to sort it out and sift it out. We wanted to establish how it should be done and what's the best practice, having the data come directly, natively to that environment. So we set up remote monitors against the production environment to see what was going on. We could get a far deeper view if we put things in the production environments with agents and stuff, but we didn't want to touch production directly. So we used remote monitoring and still were able to get some very tangible results. So this is the high-level architecture for what we set up to kind of get the basic concepts and get information directly from production to show the benefit of having an end-to-end solution leveraging event management to give us a better view of what we should be focused on. So the next thing that we needed to do was we needed to take a look and say, now we need to establish a good, solid hierarchical model. And There were static models in place, and the static model are very flat. It has a business service at the top, and then there's a bunch of things that we know in some way impact that business service, and so there's just a very flat model that's in place. What we wanted was a hierarchical model so that we can deal with not just reacting to a failure at every point, but when there is in fact some redundancy in place, we would understand how to send up an alert for that particular causal CI that was impacted, but also understand that it didn't necessarily have a complete negative effect to consider the higher level business service as being down. So those are some of the trade-offs and things that we were trying to move toward as far as having a hierarchical model. So we wanted to focus our attention around establishing not only a model, but then ensuring that we published that model into the TSOM instance and took that CMDB instance as a system of record for the model. And this was a Visio, high-level Visio diagram that they were working from before to some degree of scope. We were targeting to get this done within about 5 to 6 weeks. And that's from the standpoint of getting the hardware, installing the hardware, setting up the hardware, installing the software, configuring the sandbox environment, all of that in place, getting a model in place, and having this information flow all the way from discovery to the CMDB into the TSOM environment, get alerts that were configured to read that information in the context of that model, and then also configure the system to create the incident and outage records or unavailability records when those events were appropriate based on the policies we've established. So we drew a dotted line, or we drew this red box line around the area of the larger model we wanted to focus on because we wanted to keep this one a 5-week window. We were strategic about this because we knew in this window there were certain hotspots with the MongoDB, with FTS, and certain things in that environment that were consistently coming up as errors that were leading to outages. So we targeted. The other things that are below that red line, they were pretty stable. They were pretty okay. They still had their issues, but the primary hotspot was within this red circle. So we did a model around those items. Once we had that in place, we also then started taking steps in order to understand how to configure the level of monitoring coverage, and we'll talk about that in a minute. They were already doing monitoring, but it was more operating system level monitoring. We wanted to get something into the application level monitoring of the system, of the service that we were focused on, and we'll talk more about that in a bit. To that end, we added additional monitors. These are all the monitors that we put in place, and these are all remote monitors for TSOM. So there's 38 additional monitors, but more importantly, they had already monitors around OS, the operating system level. There was some logging that was done. There's some database, there was some network work. But the real key point was that we didn't have in place in that environment what we would generally refer to as application level monitoring. What this means is for the service and for the application that you're working with, looking at characteristics, services, log files, processes, tables in the database that had information in it that was specific to how that application works. We'll see examples of that. But just as a very specific example, FTS is a function of the remedy architecture, and there is a process, an FTS plugin process that runs. So it's one thing to know the CPU utilization of the server that FTS process is running on. Did it go up, go down? But it's another thing to know the processes that are running on that server that are specific to the remedy environment. FTS is one of them. There's several others, and putting monitors specifically around those processes, paying attention to the resource focus area for that resource. So if it's memory bound, you want to pay attention to its memory utilization. If it's DASB or storage bound, or if it's CPU bound. So you want to pay attention to whatever is appropriate for the particular area that you're focused on. If you're looking at files or looking at records in a table, there's a queuing mechanism that goes on. You put records in, you pull records out in order to support the process of that application. Well, we know that if there's too many records in this particular table, the system starts slowing down because it's trying to process all those records. Now, why there's so many records, we don't know. But what we do know, and I'm making this up, if there's more than 1,200 records in there, the system starts slowing down. So what you want to know is, for that table, are there ever records that gets above 800? And if it does, I want to start understanding why that's happening and not going down. Is it not only above 800? Is it staying at 800 and then going to 900? And I want to get in front of it before it gets to 1,200. That's the kind of proactive activity specific to that application we wanted to focus on. And also, more importantly, we wanted to look at synthetics to simulate the customer experience. Right? Now, this next slide is an eye chart. It's not intended for us to go into detail here, but this was kind of just kind of summarizing the monitoring that we put in place for that window of time for the proof of value, proof of concept. We went through an exercise with the customer to say we are going to be very specific about what monitoring we're going to turn on and what monitoring we're not going to turn on. And this is kind of a summary chart. It's not here with the intent of you kind of looking at all the different things, but there's a very specific process and focus in order to limit the scope and still get the results we're looking for. There are way more things that we can monitor in the environment. We wanted to hone it down to the areas that hit the hot spots that were most important for the customer and still be able to pull things together within that 5-week window. And then finally, once you have the model established, once you have the alerts configured, you're tuning the system and figuring out when you create, and it's appropriate to create an unavailability record based on an outage, or when you're going to create an incident, we then want to make the connection between having the tickets now get generated in the incident management system and when we get unavailability records created in the service management system. Okay? And what are the policies that are in place, and what are the thresholds and the triggers to allow that to happen? And it's definitely not triggering on every single event that comes on. All right? So, if we start taking a step back, we'll take a look at this was the BPPN view that they were looking at. This is not intended to disparage this view. It's the one that they're used to. It's a heat map. It has its function. It has its purpose. It does give you some view of what's going on. But the challenge that the team had were twofold. Number one, with this view, it didn't really have the service level context that they were looking for to understand when something's going red. What does that mean relative to a specific service? It does give you some heat maps to understand where things are, but it wasn't to the level of looking at things from a service perspective. Number two, it tended to say a bit static because they were using static models. There was no ability to understand the benefit of having dynamic or the hierarchy get reflected. The models were static and they got represented here. There were new components that were added in there. We didn't see that kind of shift in that change in the environment or the change in the model proved to be a benefit from this view. So the view is still valid, but it was limiting in what it was showing us. So just to kind of anchor this point a bit more, what we wanted to do is talk about and emphasize that other portion of the flow, which is ultimately we're going to be looking at getting information and determining which alerts are relevant to create tickets in the service management, or more specifically in the incident management system. And this also leads to when do we create an unavailability record based upon an outage. And an outage is not necessarily also always defined by something the service went down. An outage can also be considered when there's degradation that is sufficient that requires attention. Right? So at level one, all you're getting is the things that happen about the event. And you will always have circumstances where you won't necessarily have a CI that's represented in the CMDB for something, but there is an event that occurred that you may want to act upon. For level two, it is when you associate the CI, the specific causal CI for which the alert was reported against. And for level three, we have two ways to kind of leverage this. I kind of talked about static models as if they're a bad thing. They are a very good way to start. And in fact, frankly, most of your environment will be represented by static models. There will be a subset of your environment that you will leverage and focus on for hierarchical models. Those are the services that are most important to your business. Those service models evolve and mature over time, and you invest effort and time into maintaining that hierarchy as the environment evolves so that you can deal with responding to situations that occur and that context is very important. There's an investment around those. So if, for example, you have something on the order of 22 business services, it's not uncommon that you say, look, for these 22 business services, I have 5 hierarchical models, and the rest of them are static models. Because it takes effort and energy, and it depends upon your people and your processes to maintain those items. If you don't have any, you start with one, get that right, learn from it, and then you evolve it before you do the second one, and then the third one. So you're going to get to a subset, but most of your models in your environment are going to be for business services that are not as high a priority as other business services. And for those, it's okay, because if you have a static model, it's perfectly fine. But for the higher end ones, you want to take advantage of having that hierarchy in place so that you can understand those are the ones that get the most attention, get the most resources around to focus on reacting to them when they occur. When you have the ability to work with these actions and understand when this fails, I want to understand what it means in the context of the service, the higher level service that it's impacting. You'll be able to then create a causal incident. And we have 2 models in which you can represent that in this incident management system. You can create just the causal incident and then associate the higher level business services that are impacted by that causal infrastructure incident. Or you can also create incidents for the services that were impacted. And those incidents are not intended to be counted among the metrics that you're using for your causal incidents. Those incidents are intended to facilitate communication. They're intended to facilitate having meaningful service level management reports. So when I understand how I'm performing against my SLA, I can do it in the context of an email service, not in the context of server 152-7. I can leverage proactive notification to the service owners about something going on in the environment that's impacting their service. And it facilitates reporting and analytics that you may do for the system. These layers, this layer that we're talking about, these service incidents, these impact incidents, they are managed based upon the causal. You work the causal incident, and the way the system is set up is as you close the causal incident, all the other top-level service incidents will be closed automatically as well, right? So you're not trying to manage 4 different incidents. You really have one causal incident. That's the one you do your infrastructure service metrics, your MTTR against. You work the causal incident, but the other ones are more informative incidents to manage your business layer so that people can get the benefit of understanding what's happening at the lower levels and what that means relative to the higher levels in your service management space. Okay. So hopefully what we've done is been able to lay out the landscape to understand first the problem statement. We have instability going on. It's largely driven by the fact that we're operating in a reactive mode. Things happen. The customers, even though you have monitoring in place, the customers are acting as your event management, your event monitoring system. Because you're getting alerts, but you're numb to the fact that they're just ringing on the regular basis. And it's only when customers call in that people wake up and say, oh, okay, the system's down. It's really down, so let me go act upon it because clearly it's affecting someone. And the goal is now to pivot to go into a proactive mode of operations, to be in a mode where you're looking at anomalies before they actually affect the end users. And how do you do that? You try and do that. You focus on doing that. One way to do that is take a very close look at your event management system, take a very close look at how you're managing and configuring alerts, creating dashboards, elevating your view from specific events, and looking at them in the context of the higher level service, having that context, and looking at anomalies along the way. So what we're going to do is we're going to bring up a brief demo that is going to show those views, and from those views, how you then would say making some informed decisions about when you want to start triggering alerts when you get degradation of service, not when the system is falling over and customers are calling in. So let me do a brief shift here. So what I'm going to do is take you through a flow of the environment. These are the actual views of the environment, of the production environment. Now, To that end, we kind of mask some things out. That's why you see some blurry spots in place, because we have to protect the customer's environment in that regard. So I hope you'll give us a little leeway there. But we thought it was important that we give you clean mock-ups, that this was actual tangible results from the customer's experience and how it affected their ability to make this transition. So we wanted to go with that and walk through that flow and show you that firsthand. Okay? So with that in mind, let me take you through and point out the fact that right now we're looking at a high-level dashboard, and one of the first starting points is looking at the fact that we're able to establish services. More importantly, we're also able to prioritize which services are more important than other services. And from this view, we can understand the status of those services. Now, in this view, we did do a mock-up of these different services. There's omnichannel, there's payment solutions, there's SIBO, there's IAM, et cetera. The one we focused on was ITSM. That's the one that we did the drill down on. We put these others up here to show a larger audience that we could, in fact, focus on other areas. So if we drill down into the service for ITSM, for the service management space, what we're going to show here is the model. Navigating here is just to show you that there is a model. This model came from the CMDB. More importantly, a large portion of this model was derived from the information that came from Discovery that populated the CMDB with another level of effort to render the next level of service, and then that was consumed inside of the event management system. The first thing that you'll see right off the bat is in the very beginning, this started off where everything was green, but then we had an event come in and it affected one of the CIs. It turns out that that particular CI was a standalone CI, and there was no redundancy behind it. And it actually had an effect that went all the way up the chain. So you'll see here, as we continue to expand out down to that CI. Now, it's very important to note, we're not showing you this to say this is what our customer is doing in order to find out what's going on. Only thing we're doing here is to show that there is a model. This is not a theoretical thing. This is a model that actually is supporting the higher level views of what's going on. So in the bottom here, you see the event that actually came in, and it resulted in affecting things up the screen. So this is the actual model of production. We sent in a simulated event against the model of the CI to have it affect things upstream. Obviously, we weren't going to try and generate an event in production and have that show through, but we needed to prove that if there was an event in production, this is what would happen. Okay? So what we're going to do now is clear out this event, reset the model such that there's nothing there. There's no alerts out there. And now what we're going to do is to show the idea of the model of the redundancy. This was the big thing for the customer that says when something comes in, if I have redundancy in place and I've got 3 entities that are supporting that environment, please don't go in and ring the bell at the service level when I'm still working functionally and I've got everybody running around as if, as if the system is down, when in fact it's not. It's just degraded, but it's still okay. And I can then focus on fixing the one element of my redundant system and getting it back up and running. So you'll notice here the system is okay, but more importantly, we just had an event come in against one of the 3 items that are reflected in this environment, for that infrastructure item. There are 2 other redundant systems that are there, and it's perfectly fine. So the service at the top, the customer is not being impacted, but because I'm able to look at this in the context of the service and where it is, I can prioritize if I'm focused, how much energy I'm putting around this versus another event which may have brought down another service in another area. For this customer, every event was given the same priority. So they were chasing everything all at the same time. In this case, I can understand now the difference between something that is impacting the environment versus something that's bringing the environment down. Now, in this case, what the system is able to determine is that another event came against another component underneath that redundant system. I've now lost more than 50% of my capacity. That is then configured to say if that happens, I now will say that I have a degradation that is sufficient for me to raise an alarm at the service level for me to go act upon this at a higher level of urgency. That's a very important distinction. You can configure the system to determine at what point you want to hit that threshold. So again, we're just showing that as a demo of how the model would work. More importantly, this is where we expect people to start, is by leveraging dashboards. And the dashboards allow you to start at the top level and look at things from the right lens to hone in on where you want to put your attention and where you want to zoom in to areas that you can then trigger alerts for people to act upon. So there's several dashboards that were built here, but we're going to go through the top 4. And we kind of evolved, we definitely evolved in the dashboard configuration. We knew we had a hotspot in an area with regard to the version prior to 9.1 of working with FTS. And there was an item that was going on based on this hardware and this environment for something else that was going on in that box that for whatever reason was affecting that process's memory utilization. And when it went above a certain amount, it caused the process itself to fail. And you can start seeing. So the first thing that we were seeing before was we just saw that the process would drop out on the system and customers couldn't get in or they would get degradation in performance. What that chart showed was that we could see that it dropped off. So we wanted to capture that. The next part was to come over and say we want to build a specific synthetic that represented what a customer would do that would be leveraging the FTS feature. So there is a specific synthetic that is going around issuing queries at a frequency so we can see how it's performing and responding. You can see off here to the right that there was a blip on the radar. But we also knew there was a memory issue. So what we did in this next chart is we showed across the servers that FTS is running on, how is it performing. So when we saw these two things together, we said, you know what, there's actually a correlation between how the system is performing and how it comes together. In addition to that, when this issue was happening, we wanted to know, is this happening at peak busy time or is this happening at low times? Is there some correlation between how many people are on the system? But what this also allowed us to do is put in place a chart because there was some suspicion that something's going wrong with load balancers because when this happened, the entire community was being affected and we weren't sure the load balancer was failing over. And in this view, you'll see, when we did this particular recording, you'll see that one of these load balancers for some reason is not carrying its load. Now, from the end user's perspective, at that time, everything was working okay, but now we have something to go work on because we were able to detect it. So what we've now done is come in and taken all these different areas, these different learnings, and put together a higher level dashboard. And this higher level dashboard gives us a view from many different perspectives to then be more proactive in how we look at things. We can now come to this dashboard and we can manage it. We can either set it up so that when there's an anomaly that occurs, it lets us know, or in an analytical state, I can look through when an event occurs or just on my problem management or my steady state management activity, I can go look at the system at any time and look at it from this perspective and notice, you know what, there was a blip on the synthetic that went from 10 a.m. to 12 noon. That's actually not a blip. That's a long period of time for something to go wrong. And now from that view, I suspect that there may have been customers that might have been impacted. And now I want to understand in other views of the system, other views of the environment, other views of the application, what else was going on in that environment at the time that this occurred. And this dashboard, the series of charts that we have in this dashboard allow me to triangulate on what may have been going on at this time so that I can go in and try and deal with that situation. So again, it's important to note, two activities are going on. At the time this happened, before it got to that peak, I should have got an alert for somebody to go in and go fix something, go take a look and immediately jump on top of this. At the same time, when I want to go back and understand why it was in this state, I can come back to this dashboard and take a look at that information. These are some of the other views. This is the application level view that you're seeing here. There are several forms that have to do with application pending form, which have records in it. We have forms that support the email engine. We have the number of records in the social bridge form. And we know that once it gets above a certain level, certain things start becoming slower, and we would try and understand why are things not being read from the queue as fast as they're being put in the queue. We can also go take a look at this very interesting hidden area which has to do with logs. We leveraged ITBA in order to look at our logs for certain error conditions that were showing up in the logs. A lot of times the system is running perfectly fine from an end-user experience standpoint, and the log is filled with a wealth of information about things that were dropping, that were showing up, but then the system recovered on its own. And the point is, if it starts doing that and recovering on its own, it may be fine for a couple of days or maybe a couple of hours, but after a certain period of time of doing that, then it starts failing and falling over on its face. Our goal is to be able to have visibility to the logs and understand things are showing up in my logs at a level that are higher than what I need to be. Let me now be proactive and understand why these things are dropping into my log, even though everybody in the environment is running perfectly fine. Right? Further down, we can look at certain tiers of the environment. And by looking at these different tiers, I can also look at the web service and see how they're performing, and start still doing some of that system level work. But more importantly, I'm doing it in the context of the other higher level activities, the other things that are going on in the system. We also mentioned the fact that we had FTS as a area, and we put together a chart specifically to understand about the working memory for that particular process. Further down, these are other charts that are specific to the application, looking at server statistics for their idle time, looking at the response time at the server level, other pieces of information. If I was dealing with some other service, it may have some other characteristics that I want to zoom in on. And notice, last but not least, at the bottom, we actually put the table that lists the events that are coming in. This was something that we were flipping with regard to the customer's experience, because what was happening is customers were starting with the event and managing it from that level. Our goal was to start at the service level. Okay? What we're going to do now is navigate to an area that deals with kind of the dynamic thresholds that also contribute to how do I get in front of these things? How do I know that something's about to or has the potential of going wrong, and I'm not overreacting to a blip? It may be okay that I got a spike in the CPU and it went above 80%, but what I care about is that it went above 80% and it stayed there for more than 5 minutes. And that is unusual on a Friday during this time of year. And the system knows that difference, right? So what we're doing now is navigating into an area that is gathering information by the system to know what is considered normal. Generally, when we put this in place, we have this run for a period of time so we can understand and derive what was considered normal and then start comparing that against the activities. So you'll note here in this chart, off to the right, there was an alert that says, hey, what's normal in the purple line is what I determine is normal. What's actually happening is in that slightly, in that orange line, and I've now noticed that something that's went above what I can be detected as an abnormality, right? And when I see that happening, it may not affect the end users, but it's abnormal, and I want to send an alert for somebody to actually go act upon this, or I want to notice this so that I can do something about it. You'll notice here that in the far right-hand side, this thing detected that something was going on that was about to lead to a huge spike. And by being able to get in front of these kinds of things, that's when we're able to detect that something's going wrong. Okay? So these are panels, these are views that allow us to get back to understanding how the system is performing, get in front of those issues, and then start generating incidents, not when things go down, but generating appropriate incidents at the right time when there's degradation in service and degradation in the performance of the system. Right? So what I want to do is go back, and we did a few screenshots at the time that highlighted things when we were in a hot spot. So we did this activity when the system was unstable. And in fact, we found ourselves, once this came up, we started using the test sandbox environment to actually figure out what was going on in production, because the other tools were not giving us the data that we need. And what I want to kind of do is pull forth some information, a gathered screenshot of observations we had at the time that we were doing the proof of concept, because it was pointed at production. We were actually getting relevant, tangible information that directly contributed to how the organization started shifting and how they started trying to get in front of things, and had a direct effect of them turning that corner from reactive to proactive. In this particular area, there is an application specific monitoring, something specific application that's looking at block processes. So in the Remedy environment, those who are familiar with threads and all that great stuff, you can catch a point when there's having block processes going on. That means things are being stalled. Queries are not getting through. And if that's happening, it's likely that the end user is issuing a query and getting a spinning wheel. Now, this happened, and we caught it in the test environment, in the sandbox environment, because we had this graph up and we had this view up. And then after this, it went away, as you see to the right. It just went away. But we were able to go back and look at other charts, other things going on in the environment at this time to figure out why in the world were these block processes showing up in the system, showing up in the environment. We did some other analysis to look at end-user experience. One of the things that we were trying to understand is what was going on with the performance. Some people were calling into the service desk and they were running on Chrome, others were running on Internet Explorer, and we were trying to understand what the performance behavior was. With these metrics, we actually determined that one browser actually worked better, more efficiently than the other browser. And this was the data to show us this, because the customer did not have a standard that forced people to use one or the other. People were using both and other things that may be in play. But here, we knew now a profile that if a customer was calling in with Explorer, we could see a different profile of their experience and their performance when things were not stable as they should be versus somebody that was running on Chrome. And if they were running in a cache mode or running without cache. And therefore, we can start providing guidance to the customer for this particular solution, for this particular app, if you have an option, and it's not a big deal to you, hey, tell you what, why don't you use Chrome and see what's going on? Or if a customer called in and they were on Internet Explorer, we'd ask them, hey, tell you what, bring up Chrome and let me see if I see the same behavior. And that would help us understand whether there's something on the client side within the configuration of that person's Explorer that's causing the situation versus something that's more systemic going in the background. This data allowed us to kind of have that insight. We weren't focused on this, but something came up in a query and we looked at the charts and it gave us insight to show that Chrome was performing better in its standard deploy configuration. Now this view here is really the linchpin that helped us move into a mode of stability. And it's very important what I'm about to describe. The move from reactive to proactive was not this magical flip of a switch and overnight we're now doing proactive and we've achieved stability. Actually what happened was we found a hotspot in the environment that established a correlation between performing certain operations in the system, generating an event or a situation where the memory of a particular process would peak, and as a result of that, it would cause that process to either get stuck, hung, or fail. And once that happened, it would start proliferating throughout the system for some reason. The key thing was we knew to correct that problem was to basically just kill and restart the process until, in parallel, we can go off and work what was going on within the process. It turned out that it was an open source library somewhere that had a leak in it that was showing up in the environment. But we had engineering going on. But we can't wait for engineering to spend all that time or the research to be done in the background and let the customer continue to have this experience. So what they put in was a SOP, a standard operating procedure that was able to detect to say whenever this thing gets to a point that it gets to a certain threshold, we put in a process that automatically restarted that process. So that way, the customer would not see the experience. So they introduced a proactive operation to restart that particular process anytime it started getting close to or sustaining a view at a certain level of memory utilization. And before it started going up and proliferating throughout the system, we automatically would be able to go in, restart that thing, and refresh its memory utilization and keep going. And the customer never saw an impact to their performance. Now, that's not ideal because the overhead of doing that on a regular basis is not ideal. But from the customer experience standpoint, I'm stable. I didn't get impacted because this is me being proactive. And then when we got the resolution to the problem, we then went back in, replaced that particular process with the updated patch, ran the system, and we no longer had to do that operating procedure. But the whole time, the customer was now considered stable. In the reactionary mode, we just wait for it to go down, customer would call in, we'd start the system over again, and we'd be in a reaction mode. Proactively allowed us to establish stability in the environment. And it's these charts that allowed us to establish that correlation and then be able to generate incidents or generate information or alerts that would allow us to trigger a restart of that environment, or if something happened that was outside the norm, generate an incident so we could figure out how we put a process in place to recover. These are other views that also talked about giving us the ability to get ahead of things. We talked about the dynamic threshold. That red line is talking about, hey, we've determined, from the systems determined, this is what I consider as normal. By the way, these red dots are showing on this particular server in my integration server group, I just noticed that something went above what is considered normal and did it for a period of time. And guess what? We kicked in the process, restarted to get it below the bar so that the system would continue to perform. We noticed that we had the same behavior, similar behavior on another integration server. But the weird thing is, when we went to this server, which is also an integration server, it didn't have that problem, right? And this gave us a clue and an insight into saying there's something about these servers which should all be the same that is not the same. And we were able to then hone in to drill down and be proactive, figure out what is it that's different about this server that is configured differently than these other servers, and then go back to the source situation and say, how did the stamp for this server come out different than these other servers? And then you go to the rec server, and it's the same as server 4, 4, and 5, and 6 was the anomaly, right? So again, this gave us insight to figure out how to be proactive into the environment to do things to improve the stability. Now, when we tie this back into service management, we kind of tend to talk about, hey, when something happens, create an incident, work that incident to resolution, and then we can get systems back in the running. We try and get in front of it when there's degradation, not when there's an outage, and there's the operative word. I'm now looking at how do I manage things and how do I define redefine what an outage is. Rather than have an outage be exclusively defined that something has failed in the environment, you're shifting your perspective to say that an outage or things are happening where the system has been degraded, and I want to be able to capture that particular event. And I want that to be reflected as what would be potentially referred to as an unavailability record in the service management side. Now, this is separate and distinct from generating an incident. There are cases where you will always generate an outage, but you may not, in fact, generate an incident. As an example, if you have a planned activity to bring a server down so that you can apply a patch or do something to it, that's a planned outage. The purpose of the event management system is I don't care why you brought it down. All I know is that it went down, and I want to record that event. And I will just capture this thing went down at that time, period, full stop. I'm not passing judgment on whether it should be down or should not be down. But I've captured the fact that something went down. Now, if it was done during the planned event, I don't want an incident to be created because I knew that item was supposed to be down. So that's why you have blackout as a feature or capability in your event management system. So I know when I put together a change request, the change request is established, and I'm going to bring the server down at a certain time. When that server is down or during this window of time, I definitely will capture the fact that there's an outage because I don't care why you did it, but there was something, an outage on that server. But I'm not going to detect it as a failure that generates an incident for somebody in the service desk to get up and figure out why it went down. I know why it went down. I did it as a part of a change request. So you put in place a blackout, and in this case, I created an outage or an unavailability record in the service management side, but I did not create an incident. In other cases, the outage will also trigger the creation of an incident. And in that case, we would also create an incident and automatically establish a relationship between that unavailability record and the incident that got created for the CI that was impacted. So that when you're going back and doing your reports, you're in a position to kind of look at things holistically and do your analysis. You're able to go back and have these things act as trigger points to drive your problem management activity. You're able to leverage SLAs against information that is on the service management side. So these are some of the key things that we went through. And let me give, again, play back the punchline. The net result is by changing the activities, changing the process, changing the resources and how they operated, and leveraging the technology in such a way that we looked at and understood what we have, we were able to establish a system of record to define a context for things that are in the environment, to then be able to understand and do analysis and set priorities on particular events, and then know which items to focus on for resolution, to do analysis, to get in front of things. That's the principle, that's the concept. It was why we were doing this test environment, why we were doing this proof of concept in this stage environment pointed at production, that it turns out that the results of us actually doing that, that output became a part of the production process side. That output followed through on affecting the resources and how they did what they did. And the next step from that was now to take this environment, which was a sandbox staged environment, although pointed at production, and now full board take that and deploy that as a production instance of that environment. But that sandbox environment is actually even still being used as a part of the production, the monitoring of production, generating alerts, and generating tickets in the staging environment just to take a look at, because we didn't want to touch the production environment. But as a result of that activity, bottom line, not by flipping a switch did the customer go to stability, but by going to proactive modes of operation, they were able to take steps, take procedures, and put in operations that affected the environment that mitigated, minimized, or eliminated the end user's experience of being down. And even though they had to do some internal work to kind of, maintain the system, correct it on its own, they still were in a position to prevent the customer from experiencing an actual hard outage. What we have here is just a few references to give you some areas to take a look at that will give you some insights into the different areas of the solution, the swim lanes we talked about, which is discovery, the CMDB, event monitoring, service management. But the closing slide that I'd like to put in place before we start opening it up to questions is these following bullets. Now, there are other takeaways from this, but these are the top items. And when we went top, I was only going to actually list 3 or 4, and then I just kept going and going, and it's like, okay, I got to, there's a lot to be taken away here, but these are the kind of high-level bullets that I think have some tangible value for people to take a look at and to consider as they look at going down this path. One of the key takeaways, we want to establish the CMDB as the service model system of record. By having that service model definition in one place to be consumed by multiple consumers, it establishes consistency. In the customer's environment, they had a model in the CMDB, they had a model inside of event management. They were kind of sort of the same, but they were not. They weren't correlated per se, and it got in the way of their ability to be able to have the context that we ultimately were able to establish by giving a single system of record for that model and have it be consumed by the different consuming environments. We wanted to shift, when we put in place service models or models that you have in place, we want to shift from static to dynamic models. And, don't get caught up around the word dynamic. It's more about hierarchical models that you would put in place. Static models are a good step, and they actually will apply to much of your environment. But for those key services, you want to focus on having dynamic hierarchical models in place so that as your environment evolves, you're able to reflect that in your model and then leverage the benefits of understanding where you have redundancy, where you have things roll up through the chain to affect your higher level service. So that's why the key word is where it makes sense, okay? Another key thing, when you're working with an application, I talked about being able to monitor aspects of the application and not just monitor infrastructure areas, operating system performance, CPU on the box. Yes, you can do all of that, but where the real tuning comes in is where you're able to monitor the characteristics of the application itself that you're focused on that's supporting that higher level service. Right? And that's getting into these particular log files of that application have information in it that I want to pay attention to. These particular services that are running on this box use memory in this way. I want to pay attention to that. That's why it's important to collaborate and work with the application owners, because they're the ones who understand the nuances of the architecture of that application so that you can understand what's going on. Okay? The analogy is very similar to the fact that if you come into a doctor's, you go into a doctor's office and you're trying to get, a health check. Okay, if you just, take my temperature and just say, what is my temperature for my entire body? Okay, that's one piece of data. And if it's high, of course, that will tell me something. But if I'm generally not feeling good, my temperature's fine, then there's other probes that you would put in place that are specific and unique to the function of my body. How is my heart doing? You know, how is my liver doing? How are my lungs taking in air? You're looking at certain aspects of your system to know where the problem may be, and if something starts degrading in that area, how can I do something to get in front of it? That's the same thing, the same level you're trying to get to as far as tuning and doing monitoring around the application layer. And that's what you want to collaborate with the application owners, and that's what the next bullet is about, is expand the coverage to include application component level monitoring. You also want to shift to top-down service-oriented views versus bottom-up event management. One of the shifts in the behavior of the folks in the team, and it was an interesting thing to watch, especially as we had been engaged during this environment, was to get them to stop going to the form that had, you know, 32 events up there and trying to look for the red ones. And then, okay, which of these red ones should I focus on? And get them to start looking at a dashboard that would give you a view of what's going on at a level that makes sense relative to the end user experience or to certain elements in the system. And from there, you hone into the event that may be relevant for you to focus on. From there, you determine when you need to generate an incident for somebody to basically act upon. And it was very interesting to watch the team start gradually move from looking at the lower level list of list of events, and start getting more comfortable with looking at the top level view and starting to triangulate around the area that they should pay attention to, and then look at the event that specifically came in with that context in mind. That's a shift in how the resources actually were doing their job. And it made a huge difference in how they reacted also to when things came into the environment and affected the system. Leverage incident system to manage what to do when. So I kind of made this point throughout. This was another shift in behavior, which was stop chasing events, stop chasing squirrels, and please go off and shift your focus to act upon the things that result in incidents. Now, you only get there because you've tuned the system to filter down on the things that you should pay attention to. So, of course, you got to do your homework on the analysis and figure out the thresholds and the monitoring the pieces. But the point is, stop chasing events. On the reaction side, or not reaction side, but on the side of dealing with something as an alert, you want to deal with it and bring the energy around when an incident is created. From a day-to-day operation standpoint, you can do analysis on a steady-state basis to see if there's some anomalies that are going on in the environment before the customer even has a problem. Customer may be perfectly fine, and you see something happening in the environment that the system says, this is not normal. Let me go work that issue before it actually becomes an issue that would affect customers down the line. Ticket assignment primarily managed from ITSM, not event management. This is kind of a sidebar thing. One of the other things that were going on in the environment is that the customer was doing routing to the service desk resources, and they were determining that based upon characteristics or deriving that from the event management system and assigning it to a group or assigning it to an individual, and things were just getting into a queue, and the tickets were actually not being routed, or they were just queuing up. And if there was a change in the organization that was not coordinated with the people who were managing the definitions that were on the event management side, then you had things that were out of sync, et cetera, et cetera. It doesn't mean that you don't ever take certain events and say, I needed to go specifically to this group, but the key thing is to acknowledge that the primary place for defining how you route things to what group in service management is in the service management application. So send over the information about the event, about the CI, and then leverage the facilities of service management to determine how to route this to the right group or the right person based on the CI's location. You can do it based upon the CI's categorization. You can do it based upon a variety of things that allow you to automatically route this particular item to the right resource or to the right group. The next item has to do with leverage the CMDB categorization, which is the point I was just making, to drive automated ticket routing. This is the reason that it wasn't being done before, because the classification or the categorization definitions in the CMDB were not established. Another important thing is, how do you know when you're getting better? What you want to do is establish baselines of metrics so that you know that this is where you started, and now you're in a position to say that based upon what we're doing, yes, I can say I'm stable because people aren't calling in as much, but to have metrics that actually anchor that, it helps you understand whether you're getting better or not. Typical metrics are MTTR, that's one player, are we getting better at solving issues? We did see the results of that with this exercise and with this journey that the customer has taken. And then there's looking at the SGE, UGE visual. What the SGE represents system-generated events versus user-generated events. This is the case where you look in your system and you say, for a given CI, for a given event that occurred, that resulted in an incident, how many times, how many tickets are coming in as a result of my end users calling in versus this ticket was actually created as a result of my monitoring system catching it before my end users coming in. And ultimately what you want to see is a shift. If you know in the very beginning your end users are acting as your true hit management system and you're doing these type of things to go from from reactive to proactive, once you start trending toward proactive, you should start seeing more things coming in from your system and fewer things coming in from your end users for those given CIs or those given items that come in play. So understanding that ratio of what you have right now, and as you make some of these changes, how to keep that as a metric to know that you're actually getting better is a good thing. Not the last one, but the last one that we'll emphasize as closing, which is why it's in red. It is extremely, extremely important to note that please complete the entire people, process, technology consideration before you switch over to go live with this stuff, okay? You can put technology in place. The customer had all this technology. They had discovery, they had a CMDB, they had service management, they had event management. Now, there was a technology layer that allowed us to tie it together, but that also drove through, I'd say, 60% of the benefit of being able to turn that corner is taking a look at the people and the process side, changing and having people start looking at things in a different way, putting in operating procedures that understood, let's look at the degradation as our first priority rather than trying to chase down any time a customer calls in. And changing that behavior or influencing or giving people to kind of break those habits of looking only at the events can take some time. But once that was done, it actually directly contributed to some of the dashboards because people started having input to start saying, you know what, this is a dashboard that will allow me to look at things more holistically and start thinking in terms of seeing anomalies when they occur and maybe deal with them before they happen 22 times and on the 23rd time it causes the system to go out. And so having that change in perspective come into play. Also the process side. How do you tie in your problem management activity? How do you organize your group so that you have people who are looking at the analysis portion of it? How do you set up your alerts? Because you're not going to have people looking at the screen 24/7. So how do you put the right alerts in place? And when an alert does occur, when the assignment does occur, when you route the things to the right people, how do they leverage the incident, document the incident, and start dealing with things that tie into a whole nother opportunity for a webinar is the remediation process, which ties us into discussions about automated remediation that you can now start spawning from these environments. And kind of one of those automated remediation opportunities for this activity was that example I gave you, where the process, when it gets above a certain memory threshold, it starts tipping out right around 10 gig. What we did is we looked at it when we got to 8 gig and it stayed there for more than 2 minutes. Basically, we restart the process. We got to a point where we knew that it would be okay for about 24 hours. So the customer put in place every morning at 4 a.m. we would restart that process until we got the patch that was necessary to fix it. But when we did that, customers stopped having problems. They stopped getting disconnects. Okay? So hopefully this proves and helps you understand more than just the concept and the theory. And that's why this last bullet is so important. It is not just about technology. It is understanding the whole end-to-end process. It is understanding how you make the connections between these processes. It's also looking at how you change the behavior of the resources that are focused on these issues and shifting that paradigm from reactive in your default mode of operation to proactive, giving them the tools to do it, and then putting processes in place to support that. And hopefully we shared with you some tangible things that you can look at and do in order to get to those kinds of results. The interest in doing this here was this was not just a theoretical conversation. Actually what we're doing and what you're seeing is a replay of an actual set of events that happened with our customer. Okay? So to that end, I'd like to hand it back to Greg and open it up for questions in the time that we have remaining.
Thank you, Darius. Thank you for taking us through this information. And at this time, it is Q&A time for anyone that has a question. Amanda, can you provide instructions to our callers to signal us for questions?
Yes, thank you. If you would like to ask a question, please signal by pressing *1 on your telephone keypad. If you're using a speakerphone, please make sure your mute function is turned off to allow our signal to reach our equipment. A voice prompt on the phone will indicate when your line is open. Please state your name before posing your question. Again, it is *1 to ask a question, and we'll pause for just a moment to allow everyone an opportunity to signal for questions. At this time, there is no questions.
Okay. Darius, can you provide some just timelines on what this process took, the different stages maybe, to just put it into time blocks for me?
Yeah, there's two views to consider this. The one view was we worked backwards because we wanted to put in place a proof of concept, a proof of value activity, which is designed to operate within a short window of time, relatively short window of time. And, you know, you're able to cut some corners because how you set the environment up. So for that environment, we gave ourselves 5 to 6 weeks to get this up and running with the results. Plus we needed to get to the thing that establishes the baseline of what's considered normal. My understanding is it generally runs for, we generally want it to run for 8 to 14 days for it to understand that, okay, this is what's considered normal. So that was kind of baked into this as well. So for that activity, we were able to do this within the 5 to 6 week window. If I look at the steps that come into play, step one, let's not worry about the particular because we did some parallel processing here. But once we have the environment set up, the staging, the sandbox environment, we had to work on the model. The model and getting the model right for what we were looking to do, that actually took up a good chunk of our time because there is information that Discovery can do to pull out information about what a model might look like, but you've got to hone the model down to the impact model, the impact elements of the model that is relevant for event management. Discovery is not putting together a model when it discovers stuff that cares about so much who the consumer is. It's trying to find what's out there and draw the relationships, dependency relationships, impact relationships, whatever the case may be. It's putting that all together. But you got to hone the model down to the consumer. In this case, the consumer was event management, and therefore you want to take those elements from that broader, detailed model down to the elements that are necessary for the impact model. Excuse me, for the impact model that's going to be consumed. So that's in that window. That's the one that was the long pole that we had to work with. Plus, we had to get the customer to be very clear about the scope of that service. From there, once we have the model, we have the it was very short. It was pretty straightforward to get the publishing, get the configuration item, to get the things to move from the CMDB to the event. That's technology configuration. Once it was over there was the activity of getting the events to go over to the service management. That was pretty straightforward. The next the next pole was the tuning exercise on the event management side. You know, what things do you focus on? What dashboards make sense? Where do you want to put correlation for things that allow people to look at something and draw conclusions so that they can act upon things that are going on in the environment in a proactive fashion? So that was the model, and having that tuning and analysis on the service management, on the event management side were for the longer poles of things we focused on. Now, when you take that to production, okay, and you're saying, okay, now I'm going to take this sandbox and I'm going to actually deploy this in a full-fledged, redundant environment where the setup, the configuration, and the activities that go on that you have to do to set up that environment, everybody, I think, can appreciate whatever it takes for that customer to get the hardware and get things in place in order to stand up that environment. Okay, that's one item. But the other item still is going to be what's the service you're going to pick and how far can you go in order to get an effective hierarchical service model. In that case, it's difficult for me to give you a window because it depends on how much you have your organization to be aligned. When we did this POV, everybody was focused on this particular service. And it was very good. It was very easy to get support and energy around defining what the scope is for that service. Once you have that kind of commitment and focus, then it's just a matter of tuning that activity. I expect it to be something that you could spend anywhere from 2 to 3 weeks doing or longer, depending upon how much you have your team focused on getting that service model in place. Once that's done, then again, the people process side, you're now working across organizations. You're going to have to make sure, specifically when you go from event management and you're starting to coordinate tickets that get created inside the service management space, how they're going to get routed, under what conditions these tickets show up. Do I just show causal tickets, or do I want something where it shows causal tickets and the relationships to impact tickets, so that the service manager and the service management people who are just counting incidents, they can actually add filters to their queries and to their reports so that they don't see all these extra tickets that are just impact incidents, impact service incidents, as opposed to the causal incident, which is what they should be counting. So you have to coordinate activities between those groups. That's the other long pole of making sure that you have both principles to the table and they're both looking at the end-to-end solution and not just focused on, I want to keep doing what I'm doing and I need to tell you what you shouldn't be doing to impact what I'm doing. Because I don't know what you're doing there, but this is how I do things, and you're trying to throw stuff in my system and it's messing up my reports. They both need to come to the table looking at the bigger picture and the bigger goal, and that generally is supported by a high-level sponsor, with both of those representatives reporting to somebody higher who's telling them, I need to look at stability and I'm going to do it because you guys are acting in a reactive mode. I want to go to proactive. Let's figure out how these things and these processes are going to align. How long that takes really depends upon the organization and the commitment from the top down to drive the right behavior for those discussions to go well. So I couldn't say, hey, it's 7 months, 6 months, 3 months, but I hopefully helped with what are the long hot spots, what are the long poles in trying to do these types of activities.
Thank you, Darius, for the extended answer. I have one question here. It's can this tool be integrated with Atrium Orchestrator in order to fix any issues that we may find proactively beforehand?
So when we say this tool, it's a good question. There are a couple of areas in which Atrium Orchestrator can be launched in order to do remediation operations. You could launch Atrium Orchestrator from TrueSight to be able to trigger an automated activity. You could do it from TrueSight. I would offer as a best practice or as a or strong guidance is that you leverage the ability to generate Atrium Orchestrator from the incident management system. So you leverage incident management to create an incident, the event management would create an incident. When that incident is then created, you can leverage the task subsystem. So the task subsystem can then trigger or set up the integration so that it will trigger the Atrium Orchestrator activity. The reason I offer that as an alternative, both products can do it either way, but the reason I offer that as an alternative is when you do it from the incident management system, what you're doing is you're saying, I've recorded the incident itself, and the incident is now spawning the remediation activities that I want to run with. The reason for doing it from there is because I can now leverage that conduit independent of whether the ticket came from the event management system, from TSOM, or whether a customer called into the service desk or they submitted something into my service request portal. Because those last two conduits would potentially generate an incident, and therefore an incident would then spawn the automated remediation if it determined that it related to what was submitted. And if you had it from TSOM, it would also generate an incident, which would trigger that automated remediation. But if you just trigger it from the event management system, and it's the only thing that's triggering AO, then when you get something that comes in through one of those other conduits, from one of those other channels, then you don't have something in place and automatically spawn that remediation activity, should it be relevant and appropriate. So I tend to say, you know, do it at a focal point that no matter where it comes from, be it from the automated system, an end user, or some other third party saying, hey, there's an incident that looks like this, it's addressed this situation, it generates the incident. Once the incident's created, it's from that incident that you spawn the remediation, and you can use the task subsystem in Remedy to put together what's necessary for AO to poll and get data out to know there's something queued up for it to go operate on.
Thank you, Darius. And Amanda, do we have any calls queued up at this time?
At this time, there are no questions.
Okay, well, I have no other questions in the Q&A pod, and so at this time we will wrap up this month's Connect with Remedy session. To review some of the self-help and contacting BMC, all these webinar recordings as well as how-to and other self-solve type of videos are on our YouTube channel. The Connect with Remedy schedule is available on the community site. All future and past webinars are listed here, and links to the individual recordings are provided as well as our knowledge base is available via the support portal 24/7. Normal means for contacting technical support, web, phone, and email, as well as our other social channels to contact us. Wanted to thank everybody for attending. Darius, our presenter, and Amanda, thank you for all the help you provided. This will conclude this month's webinar. Thank you.